Okay, here is a session in which we are going to be talking about hyperbolas. They're the fourth conic sections of the ones that we are going to talk about. And hyperbolas are interesting kind of shapes, probably something that you don't see a whole lot, but yet there's lots of examples of hyperbolas around. Many of the planetary kind of um, orbits we used to think were ellipses, but some people now think comets or some of those other shapes may have hyperbolic paths as opposed to elliptical ones. Anyway, we're going to look at hyperbolas, and basically we're going to look at characteristics of a graph and an equation and see how the two interrelate. Just before we do that, just a quick little review on the three conic sections we've looked at already. Remember that a parabola we defined as being the locus or set of all points that are the same distance away from a fixed point, a focus, and a fixed line, a directrix. So I might have a point in here, and that might be my parabola. This distance we saw from the focus to the vertex we called P. And when we looked at the equation for a parabola, I'll just do one or two of them, they could have looked like this: y squared is equal to 4px, something like that. That would be of a parabola that would be centered on the origin, where the vertex is on the origin. Or I could have another one where it was like this: x minus h all squared is equal to 4p y minus k. And this one would not be on the origin, the vertex wouldn't be, it would be on a point of h and k. In each case though, there's information that I get about the graph over here from my equation. And that was what we played with a little bit. Looked at a graph, made an equation, got an equation, manipulated it, maybe if we had to, made it look like the graph, or got characteristics of it. A circle, set of all points that are the same distance away from a fixed middle point. Whoops, middle's over in there somewhere. And the equation of that looked like this. If it's centered on the origin, it would look something like that. If it wasn't centered on the origin, we had an equation that looked like this. Y minus k squared is equal to r squared. And again, from the equation, I could determine the center of the circle and what the radius was. The definition of ellipse was a little bit different. It was a funny one. We had two focus points, and an ellipse was defined as the set of all points such that the sum of the distance between any point on my ellipse to the first focus, we'll call it focus 1, is this. So the sum of the distance from there to there and the distance from any point to a second focus, so the sum of those two distances were always the same. So if this was 4 and this was 4, my sum was 8. Anywhere else along the ellipse, if I took the distances there, there, and there over to there, the sum of that would always have to be 8. Equations we saw for that looked like this. We're at x squared plus y squared, and you can do the ones that are moved off of the origin as well. They would have an x minus h, just like a circle did, or just like a parabola did. So x squared plus y squared is equal to 1, and this time we had fractions or rational equation or relationship, where on the bottom I had an a squared and a b squared. In this particular case, that ellipse would be lying down. If I had one where I have x squared plus y squared over b squared over a squared, if I had my equation of ellipse that looked like this, then it would be up on an end. And the only way I could tell the difference between these two is the size of the number. So the larger number was always A. In other words, A is always greater than B in an ellipse. And actually A is never equal to B, otherwise it would be a circle. So A is always greater than B. So that's the same kind of thing that we're going to look at today with hyperbolas. So here is a normal looking hyperbola. This is one that has sort of as its line of symmetry, axis of symmetry would be the x-axis. And of course we're going to have another one that's upside down or that is on the other axis. Some points that we need to know about this hyperbola are distances from the middle out to one of the vertices and from the middle out to one of the focus points. So from the middle to a focus point we call that C. From the middle to a vertex we call that A. There's another distance that comes up out here somewhere. We call that distance B, and that's one of the distances that arise when we draw asymptotes, which we'll talk about in a second, of hyperbolas. Again, though, there's a relationship, as there were in ellipse, between those three letters. And often we give you two of them, and you have to figure out the third one. So the relationship is this, that c squared is equal to a squared plus b squared. With an ellipse, that one's a minus. But with hyperbolas, it's a plus. Okay, just talking about those asymptotes, here's an example of an asymptote. Another way of defining a hyperbola is that this line approaches this asymptote but never touches. And so these equation of the asymptotes here can help us define the parabola. And whatever those equations are, whatever the values for B and for A are, help us determine what that hyperbola is going to look like. But also notice that B over A, those are values that are important to us in describing our hyperbola. This is A, distance from the middle out to one of the vertices. And B is the distance from there up here somewhere. But B and A, if I know what those are from an asymptote, I could put them here, and later I can put them on my equation because it's the same, it's the same A. Y squared over B squared is equal to 1. Okay, so I guess here I've introduced our equation for a hyperbola. This is the equation for the hyperbola. Notice it has an A value and a B value, just like an ellipse does. But the A values and B values, I don't really have a way of telling which one is bigger. But I'll show you the other formula, and you'll be able to tell which one is A and which one's B. So here's just a little slide that shows the formula right there, shows vertices as being the A value, the focus point is C, and B's up here somewhere. Also notice it shows that relationship between A, B, and C. Here's the other hyperbola that's the other way. So take a look, same kind of thing. I've got a distance for C, I've got a distance for A, a distance out this way for B. It's just that the hyperbola is oriented another way. But take a close look at the equation. Let me write it out bigger here. You'll notice that there's a difference as to where something is placed. And you've probably seen it already, that the y squared value comes first. Remember on the last one, x squared came first. In this one, if the hyperbola is oriented the other way, y squared comes first. And if y squared comes first, then a squared is always underneath that. Okay, so here's a sample question. They might say, hey, here's a hyperbola, tell me some information about it. And what I need to do is to be able to take this equation and make it look like the right kind of formula. So I need to make it look like this, x squared over a squared minus y squared over b squared is equal to 1. Right now in my equation I've got a 16 there. We need to divide everything by 16 so that I can get a 1. Divide that by 16, this by 16. In simplifying a little bit, I'll get on the first one x squared over 4. I need to call minus y squared over 16 is equal to 1. There, now I've got my equation looking in the right form. So now I have the equation in the proper form. Looks just like the one below. And I know x squared is first, so whatever's underneath x squared is going to be a squared. So I know that a squared is equal to 4, therefore a is equal to 2. And I know that whatever's under y squared is b. So b squared is 16 and b is equal to 4. So remember that a and b are distances from the middle of the hyperbola to certain spots, and so that's why I don't put a plus or minus there. Indeed, you go two different directions, but I don't put plus or minuses on this one. Okay, so if I wanted to draw this then, here I have a hyperbola, or my quadrant anyway. X squared is first, therefore it's a hyperbola that looks like that.
A bit close.
So my quadrant, and I know the distance from the middle out to a vertex is A. So A is here, 2. So the distance from here over to my vertex is 2. So my hyperbola continues this way. But it also goes the other way. So 1, 2 this way, there's another vertex of the hyperbola. Now I also want to know where my focus points are. There should be one over here and should be one over here. And I also want to know where that b value is. And b is up this way. B is 4, so up this way about 4 is my b value, and down 4 or negative 4 would be my other b value. But I don't know what my c value is. Oh, but I remember I have that relationship. C squared is equal to a squared plus b squared. And that'll give me the value of c. So c squared is equal to a squared is 4, b squared is 16. Add those together, that gives me 20. So c is equal to the square root of 20, which should be about 4.5, something like that. If you wanted to rewrite this as a proper radical or a mixed radical, you could. I like writing it, well, either is good, but I like this one because it gives me an idea exactly where it's at, or close anyway. So 4.5 or something. So if I go 2, 3, 4, 5, so somewhere in here will be my focus point. And 1, 2, 3, 4, 5, somewhere in here will be my other focus point. There I've got all of the definition kind of things that I need for my hyperbola. I guess the only other thing I could do in the end is describe what the asymptotes are. And the asymptotes for a hyperbola of this, the equation is y equals plus or minus b over a x. If I know what b is, I just plug them in. Y equals plus or minus, value of b was 4, value of a was 2, so my equation of my asymptotes are y equals plus or minus 4 over 2x. Of course we should simplify that, so plus and minus 2x, that would be the equation of my asymptotes. Okay, so all of the questions with hyperbolas are similar to that. There's just an interaction between an equation, getting an equation in the right format so that I can get information from it, and then using that information to display a graph, or get a graph and go the other way. Here's another question. So I have y squared minus 4x squared is equal to 4. Of course I'm going to divide by 4 so that I have 1 on that side. So 4 divided by 4 would be 1 is equal to 4 divided by 4 is 1. So now I have the equation in the right format. Well, I don't have anything under here. I guess if I don't have anything, I could just write over 1. This time my y value is first, therefore the one underneath that is a squared. So a squared is 4, making a 2, and here b squared is equal to 1, making b 1. And then I can follow the same pattern, do c squared is equal to a squared plus b squared, plug in my a's and b's, find c, and then graph my hyperbola. In this case, since y squared is first, my hyperbola will be coming like that. So it'll be the axis of symmetry will be the y-axis instead of the x. But you measure the distances the same. From here to here is the value of a. A was 2, so that has to be at 2, 0 up there, or 0, 2 I mean. And down here this would have to be at 0, minus 2. And my b value out here somewhere, there it is. So it's the same thing as I did with the last one. Okay, this one the same thing. This time you divide each side by a fraction. You get fractions for a's and b's. That's okay. Just this last question, I guess, that we could do is sometimes they give you the asymptotes. If they give you the asymptotes, you don't really know which is A and which is B until you know which one it is. If I have a hyperbola that looks like this, my asymptote equation is plus or minus B over AX. If my hyperbola looks like that one, then the asymptotes are y equals plus or minus, that's a plus up there, a over bx. So I have to figure out which one it is. Okay, well, they give me some other information, one of which is, one of the vertices is 0, 3. So 0, 3 right there. And if there's one at 0, 3, and it's centered on the origin, which this one is because the asymptote doesn't have anything else beside it, then those are my two vertices for the hyperbola. It must be one of these, therefore the asymptote equation is this, therefore I know that A is 5 and B is 4. I could find C, etc. I could get the equation and show a more detailed description of the picture. Okay, so those are basically all of the different pieces that you needed to do with a hyperbola. We looked at the different equations for hyperbolas, one that looks like that one and one looks like this one. We saw that there was relationships between the three variables in a hyperbola, and we looked at how we could take any equation, transform it into the proper form, get information from that, and then proceed and draw a graph of it. Okay, hope that helps in your study of hyperbolas.